Welcome to STAAD Pro-Tutorials. In this session, we will be dealing with a design and analysis of an RCC building, including slab element. So let us begin the session. Initially, start STAAD Pro. Select new project. Select space. Give name. Let the units be meter and kilonewton. Select add beam. Now, using structural wizard, you create a frame model. Now transfer this model to main STAAD Pro screen. Now switch off the grid. So this is a column element and this is beam element. Well, coming to slab, slab is designed as a plate element. As you can see, there is a 4-noded plate. You select this and you select the 4 nodes to get a plate, but there are many plates we need to form here, so we go with the option surface meshing. Generate surface meshing. Select generate surface meshing. Select the end nodes of the entire structure. Now you select quadrilateral meshing. Coming to divisions, you need to give 4 divisions since you need to form overall 4 plates. Select apply. So use the plate cursor. You can see this is a plate. In this way, plate elements are created. Now that you have created a plate element, you need to define its property. Go to general properties, define circle point 3 5. After giving circular dimensions for columns and rectangular for beams, you need to give thickness for plates, which might be nearly 0.2 meters, in the sense 200 mm. Now select plate thickness and assign to the view. Since plate thickness is assigned only to plates, so it gets assigned to plates by clicking assign. You can see. Now go to rectangle property, select assign to view. It gets assigned to all the beams and columns, but as far as we are concerned, for columns we are using circular dimensions, so assign the circular property to columns. Now you can view the 3D model. As you can see, the columns are circular and beams are rectangular, and there is a plate of 0.2 meters. Now using geometry cursor, which selects all the beams, columns and as well as plates, we use translational repeat and raise it to 8 stories. Spacing will be 3 meters between each story in y direction. You can view the 3D model. Now that You have raised it. Now you need to apply support. So create support. Let it be pinned support. Select support. Assign to the bottom nodes. Then you go to loads and definitions. Select load case details. Select dead load. Select loading type as dead. Then comes live load. Then comes wind load. Now coming to dead load, we add self weight. Then we add member load, which is minus 12 kilonewtons per meter for walls, exterior walls, and it is minus 6 kilonewtons per meter for interior walls. Then comes floor loads, which is minus 4 kilonewton per meter square for a residential building in case of dead load, and the Y range will be 3 to 27 meters since it starts from 3 and it ends roof at 27 meters. Select add, close. Now going to live load, consists of floor load, which is minus 2 kilonewton per meter square. Range will be same as dead load. Now going to wind load, you convert it into wind load x positive. Then you add wind load x negative, wind load z positive, and finally wind load z negative. Before assigning wind load, we need to define wind load. So we go to wind definitions, select add, select wind 1, select add. Now select wind 1, select add, select intensity as 1.5 meters and height will be 27 meters. You can even go to calculate as per ASCE and select the parameters as per your requirements. Select apply, then okay. Now you add it, select the factor as 1, add, close. Just that you need to select this factor using node cursor. You need to assign it to all the nodes. Now we can assign wind load, but before that we'll assign self weight to the entire structure. You need to select the entire structure using geometry cursor so as to not miss the plates, since there will be self-weight even for plates. Select assign. Now coming to wall loads, it is just for exterior walls, so select the exterior wall using control, then assign to those walls. Okay, you just made a little mistake. You delete this. Since you need to apply this to the interior walls, so you select all the interior walls and then using node cursor you remove all the columns. Okay, this way we are even having the columns, so just select the beams. Now that you have selected the beams, you can see there are no columns being assigned the load. So now you can assign this 6 kilonewton per meters to the interior beams. Now we need to add one more member load, which is minus 12 kilonewtons per meter, and assign this minus 12 kilonewtons per meter to outer walls. In this way, but the columns are getting assigned. So you just select individually the exterior beams so as to apply the wall loads to the exterior beams. Now you can see there are no columns. Now assign this load. Slab load is already assigned. Coming to live load is also assigned. Next, coming to wind load, select add, go to wind load, x direction positive, range is white, 3 to 27 meters. Select add, close. Well, you can see the wind load being applied on positive side. Coming to wind load x negative, select add, wind load, select factor as -1. The range will be same, 3 to 27 meters. Similarly for z positive, similarly for z negative. but factor will be -1, and the direction will be Z direction windward. Select add, close. You need to make a little correction. Select edit, select the direction as Z, so you can see. Now that loads are assigned, you can go to design tab, select concrete, select define parameters, select FC as 30,000 kilonewton per meter square, Fy main will be 415000 kilonewton per meter square, while secondary will also be Fe415, and the ratio you can even giving right click, you can delete the command if you have added it extra. You can go to select parameters, and you can not, so the code is ACI, but as for me the code is IS456. So you just select IS456 code and then select define parameters, which will be FC 30,000 kilonewton per meter square, Fy main will be 415,000 kilonewton per meter square, same as for secondary reinforcement. And then coming to ratio of steel will be 3%. Select add, close. Now going to commands, select design beam, add, design column, add, design slab element, add, takeoff, add. Now you need to assign this to the entire structure. Similarly Fy main, similarly the secondary reinforcement, similarly the ratio of steel. Well, coming to slabs, the ratio of steel is more. Well, we'll just skip the ratio command. Coming to design beam, by going to select X and select beams parallel to Z, we are able to design beams. Coming to columns, we select beams parallel to Y. Then for slab element, using plate cursor, we select all the plates and assign to all those selected plates. Once the design tab is over, you can go to analysis and print, select add, close, select analyze, run analysis, select save. Since coming to plates, the analysis might take some time to finish it up. However, slab element is analyzed by finite element method. And you can make as many partitions you want in this plate. So now you can go to post processing mode. You can view the deflection, you can view the beam stress is more in the inner columns. Well, we go to modeling and add a few load combinations. Factor will be 1.5. Selecting dead load, live load and wind load. X positive, sending it to the other side, selecting add. Now creating one more load combination. Z negative, and the factor will be 1.2. Select those particular loads, send it to the other side, select add, close. In this way the load combinations are created. Now you can again analyze, run analysis. Now you can go to post processing mode, view the deflection for different load combinations. Select control, roll the mouse, roll the scroll mouse. You can see the shear forces and bending moments given here for all types of loads and all types of beams, where you can get for any beam you select. You can select the plate and obtain the shear and bending moments. You can even go to summary and view the maximum bending moment shear. You can see in plate 66 there is maximum shear in one direction and minimum in plate 69. Similarly here, in this way you can obtain the maximum values. Going to animation tab, you can select deflection, select apply. Okay, you can see the deflection animation. You can press escape after you are done. You can generate reports for output with whatever you require. As you can see, output can be obtained. Well, to obtain pictures, you go to post processing mode, select the camera icon, select OK, then select another, select OK. Now I can go to reports, select pictures. You will have those two pictures. In the end, you are even given the pictures. The order should be arranged wherever you like the pictures. So in this session we learned the design of an RCC building, including slab element. You can even create plate by selecting add 4 node plate, and you need to select the 4 nodes like this in all these 4 nodes, or else you can use surface meshing, select all the entire end nodes and then give the divisions as 4 as for your symmetry possible. Here there are 4 partitions possible, so I have given it as 4. You can even divide this plate into 10 divisions if you wish. So this is the end of the session. Thank you.